June 1944, Allied bombers approached the French coast carrying the largest conventional bombs ever built. Each Tallboy weighs 12,000 pounds, 5 tons of high explosive designed to penetrate deep underground and destroy anything. The target, German U-boat pens at St. Nazaire. Massive concrete structures protecting the submarines that are strangling Allied supply lines across the Atlantic, the bombers release direct hits. The explosions are visible from 20 miles away. Dust and smoke blanket the entire harbor. When reconnaissance aircraft photograph the damage the next day, they can't believe what they see. The U-boat pens are still standing. Not damaged, standing. The concrete roofs absorbed direct hits from weapons designed to destroy anything and barely cracked. How did German engineers build structures that could survive direct hits from the most powerful conventional weapons in existence? This isn't just a story about concrete. This is about engineering taken to an extreme that seemed impossible. And it worked. To understand why these structures exist, you need to understand what was at stake. In 1942 and 1943, German U-boats were sinking Allied ships faster than they could be replaced. Over 3,500 Allied merchant vessels were sent to the bottom. The Battle of the Atlantic was the longest continuous military campaign of World War II, and Germany was winning. U-boats operated from bases along the French Atlantic coast after Germany conquered France. The submarines would leave port, hunt in the Atlantic shipping lanes, and return to refit, rearm, and prepare for the next patrol. The problem for Germany was that these bases were vulnerable to Allied bombing. A submarine tied up at a dock was an easy target. Bomb the docks, destroy the submarines, and you win the Atlantic campaign. The Germans tried various protection methods. They built anti-aircraft gun emplacements around the bases. They stationed fighter aircraft to intercept bombers. They used smoke generators to obscure the harbors during raids. None of it worked well enough. Allied bombers flying at night could still get through and damage submarines under repair, so German engineers proposed something radical. Instead of protecting the submarines with guns and fighters that might stop some attacks, build structures so strong that bombs simply couldn't penetrate them. Create fortified submarine pens with concrete roofs thick enough to absorb direct hits from the heaviest bombs in the Allied arsenal. The proposal seemed insane from an engineering and logistics standpoint. The amount of concrete required would be enormous. The construction would take massive labor and resources. The structures would be among the largest military constructions ever attempted. But the alternative was losing the Battle of the Atlantic and potentially losing the war. Construction began in 1941. The basic design was brutally simple. Excavate massive rectangular bays large enough to hold U-boats. Build walls of heavily reinforced concrete. Pour a roof slab so thick that bombs couldn't penetrate it. Simple in concept. Insane in execution. The roof thickness at St. Nazaire, one of the largest U-boat pen complexes, was over 23 feet of reinforced concrete. Not 23 inches to 23 feet. That's roughly 7 meters of concrete and steel rebar in multiple layers. Each square meter of roof contained tons of material. The total concrete volume for the entire complex exceeded 480,000 cubic meters, enough to build a solid concrete cube 78 meters on each side, but thickness alone wouldn't work. Concrete under extreme impact tends to crack and spall. The Germans designed a layered structure. The bottom layer of the roof was thick reinforced concrete designed to provide the primary structural support. Above that, a layer of granite aggregate concrete specifically formulated for impact resistance. Then a thick air gap empty space to allow blast pressure to dissipate. Then another layer of reinforced concrete. The roof was essentially a multi-layer shield with built-in shock absorption. The walls were almost as impressive as the roof. Over 12 feet thick at the base, they were designed not just to support the roof but to resist lateral blast forces if a bomb exploded near the structure. The Germans poured the walls in continuous sections to minimize joints and weak points. The concrete mix used special aggregates and high cement content to maximize compressive strength. The internal structure was compartmentalized. Each submarine pen was a separate bay with dividing walls between them. This meant damage to one bay wouldn't affect others. A single bomb penetrating the roof, unlikely but possible, would destroy one submarine at most, not the entire facility. the construction logistics were staggering. Concrete was mixed on-site in massive batches and poured continuously to prevent joints from forming. The steel reinforcement was assembled in prefabricated sections and lifted into place with cranes. Labor came from multiple sources: German construction workers, French contractors, and forced labor from occupied territories. At peak construction, thousands of workers operated in shifts 24 hours a day. The speed was remarkable considering the scale. The Saint-Nazaire complex began construction in February 1941. The first submarine pens were operational by mid-1942, under 18 months from start to first use. By 1943, the complex included 14 submarine pens, each capable of holding a Type 7 U-boat, plus dry docks for major repairs, workshops, stores, and accommodation for crews. The Allies recognized the threat immediately. U-boats operating from protected bases meant they could conduct more patrols, return for faster refits, and maintain higher operational rates. The campaign to destroy the U-boat pens became a strategic priority. Between 1942 and 1944, Allied bombers conducted dozens of major raids specifically targeting these structures. The early raids used conventional bombs, 1,000 and 2,000 pounders. These barely scratched the concrete. Bomb craters would appear in the ground around the pens. The surrounding harbor facilities would be destroyed. The U-boat pens themselves remained functional. Reconnaissance photos showed minor surface damage to the roofs but no penetration. The Allies escalated. They developed the 4,000-pound cookie bomb designed for maximum blast effect. Raids with these weapons destroyed everything above ground near the pens: workshops, cranes, storage facilities, administrative buildings. The U-boat pens stood. The submarines inside remained protected. In 1944, the Allies deployed their ultimate weapon, the Tallboy. Designed by engineer Barnes Wallis, the Tallboy was a 12,000-pound deep penetration bomb. It was dropped from high altitude, around 20,000 feet, to build up tremendous kinetic energy. The bomb would reach supersonic speeds before impact. The design included a hardened steel casing and a streamlined shape to maximize penetration. The physics of the Tallboy were terrifying. At impact, the bomb carried kinetic energy equivalent to hitting the target with a locomotive traveling at high speed. It would penetrate deep into the ground or structure before the delayed fuse detonated the explosive charge. The explosion would occur underground or inside the structure, destroying it from within. Tallboys had successfully destroyed railway viaducts, underground factories, and hardened German bunkers that conventional bombs couldn't touch. The first Tallboy raid on the Saint-Nazaire U-boat pens occurred in June 1944. Multiple direct hits were recorded. The Tallboys penetrated the outer layer of the roof. Some broke through the air gap and reached the second layer. The explosions were massive. Seismographs detected the impacts from miles away. When the smoke cleared and reconnaissance aircraft photographed the results, the Germans were still operating submarines from the complex. The roof had cracked in places. One bay had partial collapse. But the overall structure remained functional. The British tried again. More Tallboy raids throughout 1944. The largest bomb load ever dropped on a single target up to that point. The U-boat pens accumulated damage. Large sections of the roof developed cracks. Some bays were no longer usable. But the Germans continued operating from the undamaged sections. Not a single submarine inside the pens during any raid was destroyed by bombing. They were protected by 23 feet of engineered concrete that did exactly what it was designed to do. Post-war analysis by Allied engineers revealed why the U-boat pens survived what nothing else could. First, the sheer mass. The weight of the concrete roof created enormous inertia. Even a Tallboy impact, carrying tremendous energy, couldn't transfer enough force to the entire structure to cause catastrophic failure. The bomb would penetrate and create local damage. But the surrounding concrete absorbed the blast energy. Second, the layered design. The air gap between concrete layers was genius. When a bomb penetrated the top layer and detonated, the blast pressure expanded into the air gap. This dissipated energy that would otherwise transfer directly to the lower layers. The air gap acted as a shock absorber, something the Allies hadn't anticipated in their bomb designs. The irony is that the U-boat pens became militarily irrelevant not because of bombing but because the Allies won the Battle of the Atlantic through other means: better anti-submarine warfare tactics, escort carriers, long-range patrol aircraft, breaking German codes, and improved convoy systems. By late 1943, U-boat losses exceeded their ability to sink Allied shipping. The pens protected submarines that were increasingly ineffective in combat. Here's the remarkable part. Most of these U-boat pens still stand today, 80 years later. The structures were too massive to demolish economically. French authorities tried explosive demolition on some sections after the war. The concrete absorbed the charges and remained largely intact. The cost to completely remove these structures would be astronomical. Today they serve various purposes. Some are museums and tourist attractions. Some house cultural centers and art galleries. Some are used for commercial storage. The Saint Nazaire complex is partly preserved as a historical site, partly used for marine industry. The massive submarine bays that once protected U-boats now protect boats of a different kind. The engineering that went into these structures influenced post-war military architecture. Hardened aircraft shelters, missile silos, and command bunkers all use principles learned from the U-boat pen designs: layered construction, air gaps for blast dissipation, massive reinforcement, and compartmentalization. The U-boat pens proved that with enough concrete, steel, and engineering knowledge, you can build structures that survive almost anything. The cost was enormous. The labor was exploitative. The purpose was supporting a war of aggression. But the engineering itself was extraordinary. German engineers created structures designed to survive the ultimate weapons of their time, and those structures did exactly that. Not because they were lucky. Not because the Allies didn't try hard enough. But because the math and physics were correct, the materials were adequate, and the construction was executed properly. 80 years later, those structures remain. Monuments not to war, but to what engineering can achieve when pushed to extremes. The U-boat pens that survived 12,000-pound bombs are still standing, outlasting the war, outlasting the weapons designed to destroy them, outlasting the submarines they were built to protect. Sometimes engineering done right lasts forever, even when its original purpose becomes history.